All right, good morning, Tigers. This is going to actually be your last video lesson for Unit 1. After this, you've got your last Unit 1 quiz and then your Unit 1 unit test. So let's knock this last lesson out and we'll be ready to go. So if you would, just make sure you have annotated your learning targets. And that you've double checked all your vocabulary and your correlating learning tasks. Make sure you have you've got all your stuff so that you get this unit wrapped up. Okay, so I have some notes on here because I actually worked on the Desmos activity so that this correlated with your notes. So we're going to skip ahead. Since you should be, as you're working on Desmos, you should be filling this piece out. So make sure that you're doing that. Make sure you're not just putting everything on Desmos because you can't use Desmos on your quizzes. Or you can't, I mean, even if you could, you can't go back and look at the activities you've done, I don't think. I could be wrong on that. But so make sure you have these written down on a hard copy of your notes. And we're going to just go ahead and start with task 3, solving absolute value equations. So we've looked at what the solutions look like and what it looks like on a number line and kind of how we get to this point and kind of wrapping our brains on what the absolute value inequality means in layman's terms. Okay, so we're going to start solving. So to solve, the absolute value of x minus 3 is greater than 4 for x. You need to write the absolute value inequality as a compound inequality. So based on the graph from item 7, so you should have already graphed this on your own. Oh wait, item 7, sorry, item 7 is further up, way up here. But so you should have already graphed this on your own. So the expression x minus 3 is either greater than 4 or less than negative 4. So how would I write this as an inequality? Well, I would take this x minus 3, and we know that it's either greater than 4 or x minus 3 is less than negative 4. Okay, now we're going to solve each of these inequalities that we wrote, and we're going to graph the solution. So we have x minus 3 is greater than 4. I'm going to add 3 to each side, and x is greater than 7. Okay, I also have x minus 3 is less than negative 4. Going to add 3 to each side. And x is less than negative 1. So those are my two solutions. And then I want to graph it. Well, that's my two solutions. Solution sets. That's the word I'm looking for. Okay. Okay. Yeah, that's a little messy, but it'll work. Okay, so we have the x is less than negative 1. So I'm going to put an open circle on negative 1. And then I also have that x is greater than 7, so open circle on 7. And so I've solved and graphed. So I just kind of want you to look at these two inequalities compared to the absolute value inequalities. So let's just take a look at that for a second. And I want you to think back to when we solved absolute value equations. So remember how when we did the equations, we would have our absolute value equals the positive and our absolute value equals the negative? Well, we still have that. We have the positive and the negative. Instead of the equal sign, though, we have an inequality symbol. So this inequality stays the same. This inequality flips. So how do I know when to flip and when to leave it the same? Well, when I rewrote this and kept the positive, we left it the same. Now remember, when we solved inequalities, when you had to multiply or divide by a negative, you had to flip your inequality symbol. So when you change signs, you're basically multiplying by a negative. You're basically multiplying by -1. And when you multiply by a negative, you flip the inequality sign. So it follows those same rules. You still have two separate inequalities or two separate equations, and you solve for the positive and for the negative. And then we still have that multiplying by a negative flip rule. So it's kind of combining these rules to get to the same place. All right, so let's move on to the next page. Okay, let me leave that out so I can see my answers while I do this piece. Okay, so make a graph that represents the answer to each question. Then write an absolute value inequality that has the solutions that are graphed. Finally, write each absolute value inequality as a compound inequality. So I'm going to ask that you pause the video and try number 11. And go ahead and try 11 and 12 actually. So why don't you pause the video, try 11 and 12. Make sure you give yourself enough time to get it done. And you can check back in with me in a second. Okay, so this is what I've done so far. I've left some of it alone for you to try on your own. Remember, you can always ask questions though, so don't be afraid to ask questions, but I do want you to try some things on your own. Okay, so A, we have the absolute value of x is less than 2. So when I solve that, that means that x is less than 2, but also greater than -2. And so I would graph from -2 to +2, open circle, and connected. What numbers are 4 or more units away from 0? So that would be x is greater than or equal to 4, x is greater than or equal to 4, or x is less than or equal to -4, and that would be a disjunction. It would be graphed like this. What numbers are 4 or fewer? So 4 or fewer would be a less than, units away from -2. So people are going to be like, wait, why is that a +2 if it's negative? Remember, in our formula that we did last time, it's x minus the number you're counting from. And then less than, greater than, equal to, whichever symbol you're putting there. This is how many units. So this is the number you're counting from. So if you do minus -2, you should end up with a +2 here. So I'm going to leave it here, so at least we got you to here, and you can do the rest from this point. Okay, so number 12. Again, I'm not going to fill out, I should see more than this on your paper. And we'll talk about a few things. But we want to compare these two inequalities. So it's still absolute value of just x, and then we have greater than 3 or less than 3. So in this one where x is less than 3, that means it's 3 or fewer than 3, fewer than 3 units from 0. So when you think about fewer than 3 units, you're going as far as 3 and coming all the way in to 0. So that would be an and. If you talk about their graph, since it's an and, it should be a conjunction. Their circles should be open. So you have kind of a confined range from -3 to +3. On the other hand, if I flip that inequality sign and make it a greater than, that means it should be more than 3 units out. So you start at -3 and go to the left and go all the way out to -infinity. And you also start at +3 and go all the way to the right. So this is disconnected. This would be a disjunction. So you can, you've got a couple of things you can talk about in here. If I check this, I should see more than just this. This is just kind of a jumping point. So yeah, so we'll leave you there. Okay. So I'm going to help you with these two, and then I'm going to have you do 13 on your own. Okay? So I was just checking to see how many were in there. So I'm going to help you with task 4. And this is just practicing solving absolute value inequalities. And again, if you can solve an inequality and you can solve an absolute value equation, you can do this because this is just combining the two. All right, so let's start here. Now, the first thing you're going to want to do is you want to get the absolute value by itself. Always, always, always. So let's get rid of anything else that's extra. So let's subtract the 3 from either side. And we're left with absolute value of 2x is greater than 6. Okay, so now we're going to split like we did with the absolute value equations. So we're going to have just 2x is greater than 6. And then over here, we're also going to have 2x is less than negative 6. All right. Divide both sides by 2. X is greater than 3. And x is less than negative 3. So we should have x is greater than 3 or x is less than negative 3. So this is an or. Okay, and if we were to graph this, okay, we'll go like that. And you, just so you know, you can skip numbers and stuff. Just make sure you have enough tick marks. I'm just trying to make it easier to read. So we said that x is greater than 3, so we'll have an open circle on 3, or it can be less than negative 3. So this would be a disjunction. All right, so same thing. We want to get rid of anything extra. So we're going to divide both sides by negative 3. And we'll have just the absolute value of x minus 9. Now we divided by a negative, so that flips our inequality symbol. So this becomes the absolute value of x minus 9 is less than or equal to positive 21. Okay? So when we do this, we're going to split this again. So this will be x minus 9 is less than or equal to 21. Oh no, I'm so sorry, not 21. Negative 21, the negatives cancel. 21 divided by 3 is 7. So x minus 9 is less than or equal to 7. And x minus 9 is greater than or equal to negative 7. Sorry, I had a little brain fart there. Okay. Now we're going to add 9 to each side. And this is going to be x is less than or equal to 14. And x is greater than or equal to 2. I would add a 9 on each side, just in case you didn't know. And we are greater than 2, but less than 14. So this would be a conjunction. This is an and. Okay, so 13. I want you to try on your own. So good luck. Make sure you practice, practice, practice. Especially you should have a quiz coming up soon. Okay, now I was trying to see if there was any I needed to warn you about. Now remember, you have 3 at the bottom here, and you have 3 on the next page. So just be careful. Don't forget to make sure you make sure you do all your work. So that would be the end of Unit 1. So congratulations, you made it through your first unit in algebra. So all you have left is 1 quiz and 1 test, and then we'll be moving on to Unit 2, which is functions and analyzing graphs. So thank you so much for your attention. I hope this video was helpful to you. If you have any questions, make sure you talk to one of your teachers. And I hope you guys have a great evening. Talk to you soon.